Black holes have long fascinated both scientists and the general public alike. These cosmic giants, formed from collapsed stars, possess such immense gravitational pull that not even light can escape their grasp. Yet while we understand the basics of how they operate, black holes are still shrouded in mystery. Among the most captivating things they do is the dramatic destruction of anything that gets too close, particularly stars. However, there's far more to these destructive events than simply swallowing celestial bodies whole. One recent event, involving a supermassive black hole, has shown us just how chaotic and bizarre the universe can get. It didn't just destroy a star, it used the wreckage from that star to attack another, unleashing a cosmic drama that has left scientists in awe.
What we're looking at here is a process called a tidal disruption event, or TDE. It might sound technical, but the concept is actually pretty straightforward, at least by black hole standards. When a star gets too close to a supermassive black hole, the intense gravity of the black hole starts to pull at the star, stretching it out and ripping it apart. Just picture the sheer force at work. The star, once a bright and powerful beacon in space, is reduced to a stream of debris, swirling around the black hole. This process doesn't happen instantaneously either. The black hole, like a patient predator, gradually consumes the star, tearing it piece by piece. This process creates a stunning and violent spectacle, one that scientists can observe as a flare of energy, sometimes bright enough to be seen across galaxies. But there's more to it than that. It's not just about destruction with TDEs. In fact, they often leave behind a chaotic aftermath, a swirling disk of material called an accretion disk. This disk is made of the remnants of the shredded star and acts as a feeding ground for the black hole, supplying it with material to consume over the course of years or even decades. But there's more. This story takes an even stranger turn. Another mysterious phenomenon that has puzzled astronomers for a long time is quasi-periodic eruptions, or QPES. These are soft X-ray bursts that seem to come from the centers of galaxies, often near black holes, at intervals that range from hours to weeks. These X-ray flashes have been difficult to study because they are so rare, and until recently, we had little idea what caused them. Now, thanks to a groundbreaking observation, we finally have some answers, and they're just as bizarre as the events themselves. Back in 2019, astronomers using the Zwicky Transient Facility noticed something a bit unusual. They spotted an optical flare that showed all the hallmarks of a tidal disruption event. The flare was coming from a galaxy that's about 215 million light-years away. This event was named AT2019 Keys, and while it initially seemed like just another TDE, it would soon become the key to solving the QPE mystery. The event followed the usual pattern for a TDE. A star got too close to a supermassive black hole, was pulled apart by tidal forces, and a glowing accretion disk was created from the star's remains. But what happened next was anything but what you'd expect. The models show that when a black hole rips a star apart, the remains form an accretion disk around the black hole within a few years. If there's another object nearby, like another star or even a small black hole, it could interact with the accretion disk in unexpected and spectacular ways. This is exactly what the astronomers studying AT2019 KIS thought might be going on. They figured this event could help explain the mysterious quasi-periodic eruptions, but they needed proof. So they zeroed in on the region, aiming the Chandra X-ray Observatory at the aftermath of the tidal disruption event, hoping to catch one of these rare X-ray bursts in action. By 2023, their perseverance had paid off. The Chandra X-ray Observatory began picking up regular bursts of X-rays from the area around AT2019 QIZ. These eruptions were happening every 48 hours, which was a perfect example of the quasi-periodic eruptions that had stumped astronomers for so long. Further observations from other space telescopes like SWIFT and ASTROSAT backed up what they were seeing. This was the breakthrough they'd been waiting for, proof that a tidal disruption event was the cause of the quasi-periodic eruptions. What was going on? It seems that when the black hole ripped the star apart, the remaining debris formed an accretion disk, just as predicted. But there's more to it than that. It seems there was also a second object involved, possibly a companion star or even a small black hole, which was orbiting close to the supermassive black hole. As it passed through the accretion disk, it triggered the release of energy in the form of X-rays. Each time this companion object passed through, it stirred up the superheated plasma in the disk, causing it to flare up and emit the X-rays that we detect as quasi-periodic eruptions. In other words, the companion object was crashing through the black hole's dinner, creating these periodic cosmic outbursts. This is a huge discovery, not just because it helps us understand the origins of QPEs, but also because it offers a real-time insight into the chaotic and violent environments that exist around supermassive black holes. This is the first time we've been able to observe how a black hole's gravitational forces interact with the material around it in such a way that it triggers these regular eruptions. It's a big step forward in our understanding of both tidal disruption events and the strange bursts of energy we see near black holes. But there's more to the story. Even with this breakthrough, there's still a lot we don't know. Firstly, we're not completely sure what the companion object is. Is it a star that's been caught in the black hole's gravitational pull? Or could it be another black hole, much smaller than the supermassive one at the center of the galaxy? We'll need more detailed observations to determine the nature of this object. But one thing is for sure. Whatever it is, it's playing a key role in the creation of these X-ray eruptions. What's even more exciting is the potential for future discoveries. Now that we know QPEs can be linked to tidal disruption events, astronomers can start looking for similar occurrences in other galaxies. Each time they observe a TDE, they can monitor the region for quasi-periodic eruptions, gathering more data and refining their models. This will help them build a more complete picture of how black holes and their surroundings interact, giving us deeper insights into one of the most mysterious phenomena in the universe. While this link between TDEs and QPEs is a big step forward, it also shows how much we still have to learn about black holes. These objects are among the most powerful forces in the universe, and there's still so much we don't know about them. We've come a long way in studying them, from Einstein's predictions of their existence to actually observing them with telescopes like the Event Horizon Telescope. But with each new discovery, we're faced with even more questions. For instance, we still don't fully comprehend how black holes form the extremely hot accretion disks that feed them, nor do we know precisely how they impact the formation and evolution of galaxies over billions of years. What we do know is that black holes are not just passive consumers of material. They're not just passive consumers of material. They're dynamic and active, capable of shaping their surroundings in ways we're only beginning to comprehend. The amazing thing about black holes is that they can shred a star and then use the debris to generate periodic X-ray eruptions. It's just one example of their extraordinary influence on the universe. The discovery of QPEs linked to tidal disruption events is like finding the missing piece of a cosmic puzzle. It's given us a window into the chaotic lives of black holes, allowing us to witness the raw power of gravity on a scale that's beyond our comprehension. And as we keep studying these events, we'll undoubtedly uncover more strange and wonderful phenomena that challenge our understanding of the cosmos. To sum up, this is a story of cosmic destruction, creation, and mystery. A supermassive black hole didn't just consume a star. It turned the wreckage into a weapon, pummeling a nearby companion object and triggering X-ray eruptions that have puzzled astronomers for years. Thanks to the hard work of scientists and the amazing capabilities of space-based telescopes, we now have a better understanding of how these quasi-periodic eruptions work. With each new discovery, we're getting closer to understanding black holes and their role in shaping the universe